We know that some magnet has permanent magnetic field, such as a bar magnet and a horseshoe magnet. However, a conductor or a wire can also act as a magnet when a current flows through them. This is called electromagnet, where they will only produce magnetic field when current is applied. So, these are some of the sources of magnetic field, including our Earth. The Earth generates its own magnetic field like the bar magnet. Hence, we can define the magnetic field as a region or space around a magnet or around a conductor that carries current, where the space will experience magnetic force. If you put any magnetic object, such as iron powder, around a magnet, there will be force of attraction between them. This is a bar magnet. It has two ends on the opposite sides, where N is the north pole and S is the south pole. When two bar magnets are put next to each other, the same poles will experience repulsive force, while the opposite poles will attract one another. To know the direction and the pattern of magnetic field around the bar magnet, we sprinkle some of iron powders around it. We will find that the iron powder will arrange themselves in this pattern. The field lines will always form a closed loop around a bar magnet, and the direction of the field lines will always pointing away from north and towards the south pole. Therefore, we can always draw arrow from north towards south, pointing away from north and towards the south. We also see that more iron powders are attracted at the poles of the bar magnet. Therefore, we can conclude that stronger magnetic fields at the poles. And the lines are also not intersect to one another. The field line will always form a closed loop and the direction is pointing away from north towards the south. Closer magnetic field line at the poles of the bar magnet indicate stronger magnetic field, and the field line will always not intersect with one another. When two unlike poles brought together, the magnetic field lines joining together and become denser between the poles. They will attracted towards each other. However, when two north poles or two south poles approach together, the magnetic field lines repel each other and they will experience repulsive force. This X is actually called neutral point, where the magnetic field lines is zero because the field lines coincide and cancel each other. The Earth is actually behaves like a giant bar magnet. In fact, the compass that we use in daily life actually works by detecting the Earth magnetic field. In this video, we are going to look at the Earth magnetic field and compass in more details. As the Earth is a giant magnet and compass is also a magnet, they will act the same as any two magnets when brought together. The Earth North Pole geographically is actually the south magnetic pole of the Earth. Therefore, the North Pole of the compass attracts the south magnetic pole of the Earth. So that is why we can use the compass to show the geographic north of the Earth. Next, we want to look at the magnetic field around a straight conductor. In order for a conductor to behave as a magnet, there must be a charge or current flows through it. That is why we call it as current carrying conductor. We can use the compass to help to draw the pattern of magnetic field form. It is observed that the lines of magnetic field form concentric circles. In this case, the direction of magnetic field is clockwise. If we reverse the polarity of the dry cell so that the current will flow in opposite direction, we can see that the magnetic field line in anti-clockwise direction. Why do we say that the current into and out of the page? This is to show or to explain the direction of the current when viewing from the top of the conductor. From the first picture, the current going down means current into the page or into the paper, and current going up means out of the page. This is the top view of the pattern of the magnetic field lines around a conductor. You can use the symbol X to represent the current into the page or dot to represent current out of the page. We can use right-hand grip rule to show the direction of current and magnetic field around a conductor. The thumb will give the direction of current in or out of the page, whereas the direction in which fingers curl around the conductor gives you the direction of magnetic field lines in clockwise or anti-clockwise direction. What do you think will happen to the magnetic field lines when the straight conductor is bent into a circular loop? We sprinkle some of iron powders around the loop. After some time, we will see that the magnetic field lines are produced at each point of the loop. The magnetic field lines are circular near the current carrying loop. Again, we can use right-hand grip rule to check the direction of magnetic field lines near the loop. If you look at the direction of current flow through the loop, the current here should be up and the current here should be down. Use your right hand and point your right thumb according to the current flow. You will see that the magnetic field lines on the left point of the loop should be anti-clockwise and here should be clockwise. If you put your circular loop facing in front of you like this, you need to use the symbol X like this to show the direction of magnetic field into the page. And then for the outer side of the loop, it will be dot symbol to show that the direction of the magnetic field out of the page. Let's move on to the other form of conductor, that is solenoid. Solenoid consists of long straight wire that is wrapped many times around any cylinder object to form a coil. If the wire carries a current, it will generate magnetic field around it. As you can see here, the pattern of the magnetic field is similar to that of a bar magnet. Compasses can directly show you the direction of magnetic field. From the arrow that you draw, you can straight away determine the north and south pole of the solenoid. Here should be north, and the other end of the solenoid should be south. Theoretically, you can also use right-hand grip rule to determine the polarity of the solenoid. Imagine you grip the solenoid with your right hand, so the fingers follow the direction of the current, and your thumb will point toward the north end of the solenoid. So this side will be north. So fingers will follow the direction of the current. So the current should flow from positive terminal to the negative terminal. So this is the direction of the current flow through the coil or the solenoid. Then the thumb will be pointing towards the left. So the left side should be north and the right side should be south. So the magnetic field lines will pointing away from north and towards the south. Before I end my video, let's talk about the mathematical symbol and SI unit for magnetic field. The symbol for magnetic field is capital B and the SI unit is Tesla, and we use capital T as the short form for Tesla.